So first of all, we're going to look at the reactivity series. The reactivity series is ordered with the most reactive metal at the top, such as potassium, and the least reactive metal at the bottom. The least reactive metals, we say, are found native. Native means they're found in their pure state, such as gold, silver, and platinum. The higher up the reactivity series you are, the easier it is to displace you from the metal. So how do we actually extract metals? Well, first of all, I need to find the ore which I'm going to extract the metal from. An ore has to contain enough metal to make it economical to extract. What that means is that there is enough metal in the rock for me to make enough profit from it. One of the methods of extraction I use is reduction. If I use reduction, that means I would be lower than carbon in the reactivity series. I remove the oxygen from the compound and I make carbon dioxide and an impure metal. But it's quite fast and it doesn't use too much energy. An example of this is the blast furnace, where from iron oxide I can produce brittle iron. I can then react the iron with carbon to make steel. And I've written the word equation right here for it. The second method of extraction is electrolysis. Electrolysis means the breaking down of a substance using electricity. You will look at electrolysis more in C2 for your additional chemistry. For electrolysis, it's for an ionic compound in liquid form. It is for metals that are above carbon in the reactivity series. There's also two other ways I can extract metals, and I use these for copper. There is phytomining and bioleaching. I use these on the low-grade copper ores, where there's not quite as much copper in it as I'd like. 20% of the world's copper actually comes from bioleaching. This is where I add bacteria to the leachate, and it breaks the rock down and leaves me with carbon, but it's going to be quite slow. The other method is phytomining. This is where I get a field which contains copper in the soil, I grow some plants, and then I burn the plants and harvest the copper that's left on the top of the soil. You can imagine, again, it's going to be quite slow, only happens once or twice in a cycle in a year that I'll be able to grow them, but it's carbon neutral. Unlike reduction, it's only releasing the carbon dioxide into the atmosphere that it took in through growth. You've got to know about two metals in a little bit more detail. Aluminium and titanium, both really important. Aluminium is extremely malleable. That means it can bend and it's lightweight, so I can make aircrafts out of it or your Coke cans. I find it in bauxite in the form of aluminium oxide that's got a really, really high melting point. To lower the melting point, I add cryolite. This means I use less energy, but it makes aluminium expensive when I use electrolysis to separate it. The second way is titanium. Titanium again is expensive because I have to do it in a two-stage process. It's not a very reactive metal, but I use displacement to separate it from the ore, and then I've got to remove the oxygen as well, because otherwise the oxygen would make it very brittle, and nobody wants to wear brittle body armour. I make hip replacements out of titanium because it's resistant to corrosion. That means it doesn't rust. I'll leave it on the board for a moment for you to take any notes.